All right, so this video now is going to be examples where you're going to have isosceles and equilateral triangles, maybe one of each, maybe two isosceles, maybe two equilaterals. We don't really know right now. I'm not going to lie to you, these will look really, really complicated in the beginning. You're going to have to slow things down. You're going to have to be very patient with yourself. But in the end, all we're really doing is using basic definitions, okay? So let's take a look at the first diagram. Looking at the diagram, I can already tell we have an equilateral because we have 3 tick marks right there, okay? So that means this triangle right here is an equilateral triangle. So then that means all of these angles are equal to 60 automatically because that's the only number that works for it to be, everything congruent. And so let's go ahead and let's see what else we can do. We have this right here as a 90-degree angle, and then it's being sort of split into two. Now, notice how I didn't say bisected because we don't know that, okay? So it's being split into two parts, and we know one of them is already equal to 60. And since it's a right angle, that means they're complementary. So that means this bottom one, the only thing it can be is equal to 30 in order for it to be a right angle. So right there, we already have n is equal to 30. Okay? And now to go ahead and to figure out m, right, we just look at what we have left and what we can do. So we have this triangle now. Let me change the color so you guys can see. So we have this triangle, okay? And we have a 90-degree here at the bottom. We have the 30 at the top. So if I redraw it, right, we have m here. We have 30 at the top, 90 right here at the bottom. So then this actually becomes a not so bad problem. We can just do 90 plus 30, which is equal to 120. I know this is a triangle, and so then it has to equal to 180. And so the only number that works there would be a 60. Okay, so m has to equal 60 because in the end it has to end up equaling to 180 anyways, since it's a triangle. And so there you go, right? I know this problem in the beginning looks really hard and complicated, but you really just have to use, basic definitions here. So let's go ahead with the next one. So two things I notice here, I have both an equilateral and an isosceles, okay? So the equilateral is this one right here because it has, two tick marks all around. And then I also have an isosceles right there because both of them have one tick marks. So that means I have a bunch of congruent angles here. So let me go ahead. This one, those are congruent. And then I'm going to go ahead and do this. These two right here are congruent because those are the isosceles ones. So same thing as before. I can go ahead and do 60 here because that's what an equilateral is. And then we have a really nice right angle right there. Okay, it's being split again into two. One of them is equal to 60, and so that means this one is automatically equal to 30. Since the bottom one with the two lines is equal to 30, that means this one is also equal to 30. So I already found x. X is equal to 30 degrees. Now to figure out y, notice that it's coming from the triangle here that's sort of like attached to the other triangle. So since this one is 30, and so since this one is 30, I can go ahead and figure out what y is just by doing, some kind of basic math. 30 plus 30, sorry, that looks way bad. 30 plus 30 is equal to 60, and then we know, again, a triangle has to equal to 180, and so therefore the measurement that's missing is 120 in order to get it to equal to 180. So y is equal to 120, okay? So from first glance, yes, this problem looks hard, but you just gotta, give yourself a chance. For those of you guys trying it, let's go ahead and first thing that I notice is we have an equilateral triangle right here. And then I'm gonna go ahead and use a different color, but just we have an isosceles there. So I can go ahead and start putting congruent angles in there. So I know that these three angles are equal to each other, or congruent, and since it's an equilateral, I can also go ahead and put 60 degrees for all three of them. I know for this bottom triangle that this angle is going to be congruent to that one. Notice how I am putting two lines there instead of one because I want to make sure I remember that even though we're talking about the same side length, that it's still not the same angles, right? And we talked about that in another example. So then I can go ahead and just start thinking about where can I like sort of help myself out here. One thing I do want you guys to notice is this part right here and this part. They do look very similar to 90-degree angles, but if you notice, they do not have that little red square that we're used to, basically like this one, to indicate 90 degrees. And so therefore we can't assume that that's 90 degrees. So the only thing I can do is basically work with this part right here. So there you see a linear pair, right? So this straight line and then this line. Since this one is equal to 60, I can go ahead and kind of easily figure out what this angle here is equal to. I would just do the math. It's 60 plus a number is equal to 180, and so therefore this one is equal to 120 degrees. So that was pretty easy. All I did was just linear pair there. So that already is the measure of angle C. So I'm gonna go ahead and say measure of angle C is equal to 120 degrees. So that's one already. Now we're at this isosceles triangle, and we have two congruent angles that we don't know their measurements, right? And so what we can go ahead and do is what we've been doing before. We know a triangle is always equal to 180, and then the two angles that we don't know are congruent. So we can sort of take half of whatever's left over. So if we go ahead and do it for this work, we can do 180 minus 120, which is 60 degrees. So it leaves me 60 degrees to split up between this angle and this angle. And that's really nice because I know they're congruent since the tick marks indicated isosceles. So therefore it's 30 degrees. So right there, I already figured out these two angles. So let me go ahead and write that. So this one is equal to 30 and this one is equal to 30. So if you notice, right, let's look at one thing really quickly. This angle right here is not a 90 degrees because 58 plus 30 is 88 degrees. And then this angle over here is equal to 90 degrees. So that one could have potentially had that little red box there, but it didn't for whatever reason. And so you see, that's why I want you to never assume, okay? Always do the math and like let it show you. So we actually already solved for A. So we can go ahead and do measure of angle A is equal to 30 degrees. Okay, and so now just the last one to go ahead and solve for is angle B, which is over here in this third triangle. And let me go ahead, and there's a couple of ways of doing this. We can focus on the small triangle. So let me go ahead and erase these highlights so you guys can see what I'm talking about. So for instance, you can decide to work with this triangle here, or you can also decide, and this is the one where some people kind of see it, you can decide to work with this triangle here. So if you notice, that's actually two different ways. I'm going to go ahead and do the little one because I think that's the one that most of us are going to be able to, like, hone in on. And so let's see, we have 58 over here on this bottom left, and then I don't have this angle, and I'm looking for angle B. But the really nice part about it is I actually do know what this angle is. And all we have to do is remember basics from, when we started with, I guess, geometry. We have to do vertical angles. We see this angle right here is a vertical angle to this one. And so vertical angles are always congruent to each other. And so that right there is 60 degrees. You could have also potentially done this right here where you had a linear pair with the 120 and then you could figure out the 60 by subtracting from 180. But whichever way you want. And so then we have this triangle here. We have 60 as one of the angles. We have 58 as the other one. And now it really just becomes a really easy method of solving for this one. I'm going to go ahead and add these two angles and then just subtract from 180. So 58 plus 60 gives me 118. And then the only thing I need to do is 180 minus 118, which is equal to, let's say 62, 62 degrees. Okay? And that just comes from, a triangle always equaling to 180. So measure, sorry, that looks really bad. measure of angle B is equal to 62 degrees. So if you see there, then it's really not that hard, right? You're just using basic ideas, but it can get complicated if you feel overwhelmed, okay? So let's go ahead and move on to the next example. Pause the video and see if you can try to figure out by yourself. It's a pretty tricky one, so yeah. So the first one I'm going to do is, first one I'm going to solve for is n, because looking at the picture, I can pretty easily separate it, and then it'll kind of help me out. So it's an isosceles, so you see that there. So I'm going to go ahead and redraw it, okay? So it looks something like this with my 2 tick marks, my 90 degrees, and then right there, okay? And then n. So since it's an isosceles, we know that it also has 2 congruent angles that are opposite the sides. And so that means this angle is equal to this one. This is 90 degrees. And so the really nice part here is, since these 2 angles on the right, the top right and the bottom right, they're equal to each other, I can go ahead and I can basically figure out what they have to equal to. So since I already used 90 degrees, that means I have 90 degrees left over, right? But now, since they're congruent, that means I can go ahead and divide by 2, and that's going to equal 45 degrees. So what that means is this one is 45, and this one is 45. And if you see it there, it'll be the only number that works in order for the triangle to equal to 180. So we already have n. N equals 45 degrees. Okay? And so now let's think about how we're going to do this here. So we actually have another isosceles, which is going to be a little bit hard to see, but it's actually going to cover that right there. So the 2 blue lines that I just highlighted, and then the red line. So it's a pretty big triangle. It's the one on the one that covers all the outside. So I'm going to redraw that one. So 50 goes there, and then we have no idea what the top right one is, and then we know that this one here gets separated into 2, and we know that it's 45 right there. Okay? So obviously this bottom right one is a little bit bigger than 45, okay? And the same thing as the other one too, right? Because it gets broken up. Right? So just to give you a heads up on how that looks. Okay? So both of those are 45 there. Okay? Well, partly 45, right? You still need to figure out the other ones. And so the really nice part about it, though, is that you have that they're actually, this triangle is actually an isosceles, right? So because we have 1 tick mark, 1 tick mark. So that means this angle has to equal that angle there. We're going to do the same trick we did over here. So 50 degrees is already used up. So you know triangle is equal to 180. 50 degrees is already used up. So that means you have 130 left. Since what's left over is 2. Since what's left over is 2 congruent angles, we're going to go ahead and divide by 2 there. And then that's going to give me 65 degrees. Okay? And so then that means this angle is 65 degrees and this angle is 65. But what you have to remember is 65 is going to be this entire angle, right? Both the M and the N part. But the really nice part about it is, angle M plus angle N is equal to 65. The really nice part about it is you already know what N is. So then we basically just substitute our answer for that. Okay? Wow, yeah, sorry about that. And so then what we have here is a very simple equation here to figure out what the measure of angle M is equal to. The last thing you have to do to figure out the measure of angle M is subtract 45 on both sides. And then all we're going to figure out is just angle M is equal to, 20 degrees. Okay? So there you go. This is probably going to be considered to be like the hardest one you've seen so far, but it's just because you're doing a lot of little random steps here. All right, so just as a quick little recap here, we're going to go ahead and I'm going to show you some little tricks here. All right. I do realize that the diagrams can get tricky. You just need to rely on your instincts. look for what you know, right? If you see an equilateral triangle, go with that because you automatically know that it's equal to 60 degrees. Work with vertical angles, work with linear pairs, okay? Know the basic definitions of an isosceles and an equilateral. And then I think honestly the most important part is you know that the angles in a triangle must always add up to 180, okay?